Okay guys, sorry if you had problems. Hopefully the sound is working on this one, so we'll be good to go. In the previous video, we talked about what a mole is and how many atoms it represents. And so now what we're going to look at is the mass of that many atoms. And so when we talk about a mole of an element like copper versus a mole of an element like carbon, they're going to have different masses because copper atoms have different masses than carbon atoms. There's different numbers of protons, neutrons, and electrons. And so we call that mass the molar mass, the mass of 1 mole of any pure substance. And the molar mass of an element is numerically equal to its atomic mass and has the units grams per mole. So you're going to find this number on the periodic table. When you look at the periodic table, that atomic mass that's given, that is also the mass of a mole of atoms. Yes, it's the mass of 1 atom in AMU. It's the mass of a mole of atoms in grams. So if you don't have your periodic table out, you need to get it out because we are going to be looking up molar masses. Okay, so let's talk about using molar mass as a conversion factor. So if you're given the number of moles of something and we want to figure out the mass of that number of moles, then your conversion factor is going to be your mass, your grams per mole. So for copper, if you look at the periodic table, the molar mass is 63.546. That's how many grams there are per mole of copper. So we would set up 3 moles times grams over moles. Moles cancel, and that's going to give us our number of grams. Now, again, remember the sig figs come from that very first number that's given. They don't come from your conversion factor, so we would have 3 sig figs there. Okay, so let's work an example together. Chromium, a transition element, is a component of chrome plating. And chrome plating is used on metals and in steel alloys to control corrosion. We want to calculate the mass in grams of 0.0450 moles of chromium. Alright, so like we've done all of our other conversion problems, we're going to start with what we're given, which is 0.0450 moles of chromium. So what we want to do is we want to put our 0.0450 moles over 1. Now we want to look up chromium on the periodic table, find its molar mass, and we find that 51.996 grams of chromium per mole. So our moles go on the bottom, they cancel, we multiply by the molar mass, we round to have 3 sig figs, and we get 2.34 grams of chromium. Alright, so that's how you're going to be using that molar mass in your conversion factors. Okay. Come on, there we go. So when we're using molar mass, this picture is going to help you kind of figure out how you can tie that in with Avogadro's number. So if you have the mass of something, you can use the molar mass to get to moles. Well, then remember, we can also, once we have moles of something, use Avogadro's number to get to particles. Or if we know how many atoms or how many molecules, we can get to moles, and from moles we can get to grams. So having this little flow chart is going to help you figure out what your conversion factors are going to look like as you're converting from grams to moles to atoms, or atoms to moles to grams. Okay, so let's do another problem. It says, calcium, the 5th most abundant element on Earth, is always found combined with other elements because of its high reactivity. How many moles of calcium are in 525 grams? All right, so we start with what we're given, 525 grams of calcium over 1. Find calcium on your periodic table. We need its molar mass. And this time, because we're trying to get rid of grams, our moles go on top, and our molar mass, which is 40.08 grams, goes on the bottom. So this time our grams are going to cancel. We divide by the molar mass. We keep 3 sig figs, and that's going to give us 13.1 moles of calcium. Okay, so you can use it to go from grams to moles or to go from moles to grams. Either one works. Next example. Gold is one of a group of metals called the coinage metals. How many atoms of gold are in a U.S. eagle, which is a coin that has a mass of 31.1 grams of AU? Okay, so this time we have grams, but we're asked how many atoms. So we're going to have to use more than one conversion factor here, and that's where that flow chart could come in handy to help you figure that out. So we're going to start again with what we're given, which is 31.1 grams of gold over 1. And from grams, we can go to moles using the molar mass. So on your periodic table, find gold. 1 mole of gold has a mass of 196.967 grams. So our grams cancel. Now, we want to take our moles and convert it to atoms. And according to our flow chart, to go from moles to particles, which are atoms in this case, we're going to be using Avogadro's number. So 1 mole is equal to 6.02 times 10 to the 23rd atoms. So our moles cancel, we do the math, we round to 3 sig figs, and we get 9.51 times 10 to the 22nd atoms of gold. There you go. Okay, let's do one more example. Helium is an unreactive noble gas often found in underground deposits mixed with methane. The mixture is separated by cooling the gaseous mixture until all but the helium has liquefied. A party balloon contains 5.50 times 10 to the 22nd atoms. What is the mass in grams of the helium? Okay, so this time we're starting with how many helium atoms we have, which is 5.50 times 10 to the 22nd helium atoms over 1. We have to go from particles to moles to grams. So from atoms to moles, we're going to use Avogadro's number. This time it's going to go on the bottom so that our atoms cancel. And then we go from moles to grams. We're going to need to know the molar mass of helium. So look at your periodic table, find helium. And our molar mass, 4.0026 grams per mole. Moles on the bottom, so they cancel. We do the math, and this time we round to, again, 3 sig figs, and we get 0.366 grams of helium. All right.